Hey guys, for our statistics chapter, we're going to start off with some things that should look pretty familiar to you. So, first off, we have our measures of central tendency, and those are our three M's here, the mean, the median, and the mode. So it measures the center value. So our mean is the average. That's where we add up all the values and divide by the number of numbers. The median is the middle value when the numbers are written in numerical order, and the mode is the value that occurs most often. So without using a calculator, find the measures of central tendency. So mean, we're going to do 1 plus 1 plus 3 plus 4 plus 6 plus 9, and then we need to divide by the number of numbers that we have. And so we have 6 numbers. So I get 24 divided by 6, and so I get 4 is the mean. The median is the middle number when it's written in order, and since we're in order, then the middle number, take away the first and the last, take away the second and second to last, and so on until we get to the middle. We have 2 here. So we find the average of that. So 3 plus 4 over 2 is 7 over 2. So the median in this case is 3.5. And then the mode is the number that occurs the most often. So the mode here is just 1. You can have 2 modes, that's called bimodal. But anything over 2 modes, you just say that there is no mode. All right, then we have the measures of dispersion, and that's how far apart things are. So one of those is the range. That's where we take the maximum value minus the minimum value. And then the standard deviation is the typical difference, or the deviation, between a data value and the mean. And we're going to get a new formula for standard deviation. And that's this formula. Standard deviation uses sigma, which looks like an O with a line coming off of it, of some number of numbers. You take big square root, and we subtract our data value, so x1, x2, all the way up to xn, x sub n. So just like on our previous problem, we had 1, 1, 3, 4, 6, and 9. Those are the numbers that would be plugged in there. We divide by the number of numbers. But on each of these, we're subtracting x bar. And x bar is just the mean. So we take the data point, subtract the mean, and then square that value. Plus the next data point, subtract the mean, square that value. Let's try these. So to find the range, highest value minus the lowest value. So our range here is 8. Our standard deviation, so sigma is equal to big square root. Now I'm going to subtract 1 minus, and we found our mean before. I'll go back a couple slides if you don't remember. Our mean was 4. So we're going to subtract 4, square it, then add our next data point. So 1 minus 4, square it, and then 3 minus 4, square that, 4 minus 4, squared, 6 minus 4, squared, and 9 minus 4, squared. All over 6. So now 1 minus 4 is negative 3, negative 3, negative 1, that's a 0, 2 squared, and then 5 squared. Now remember, when you square a negative, you're going to get a positive value. So we get 9 plus 9 plus 1 plus 0 plus 4 plus 25 all over 6. get 48 over 6. 48 over 6 is 8. So the square root of 8, I think, is approximately 2.8. So either the square root of 8 or 2.8, and you could reduce that to even 2 radical 2 if you were simplifying that radical. If it wanted exact form, then you would want this form from our square root of 4, square root of 2, breaking that up into 2 radical 2. Okay, some other things that we'll look at are statistical graphs, and these are things that you should have seen before. So we have a bar graph, we have a circle graph, we have a line graph, stem and leaf plots, a histogram using a frequency table, and a box and whisker plot. And all of these that have page numbers, these are page numbers in your book, that if you don't remember this and you don't feel like there's enough explanation, you can go back and look at those page numbers to see those specific things. But this should all be review from probably middle school. All right, Sydney's math test scores are 90, 85, 88, 95, 100, 77, 85, 100, 80, 77, and 90. Using this data, create a stem and leaf plot. Well, I notice that the lowest score I see is a 77. The highest score I see is 100. So a stem and leaf plot has 2 columns. We have the stem part and then the leaf part. So the stem I'm going to make as my tens places. So I have 70, 80, 90, and then 100. So we have 10 there. And so then you put those values in order within there. So in the 70s, we had a 77 and we had another 77. Notice I'm not putting a comma there in between those. And then for my 80s, the smallest 80 I have is a 0. And then I have 85. And I have another 85. I have an 88. And that looks like it for my 80s. For my 90s, I have 2 just plain 90s. And then I have a 95. And then I have 2 100s. So I have 100 and 100. You also want to include a key so that you know what this is in reference to. So in this key, I would say 7 bar 7 is equal to 77. And that's your stem and leaf. Okay, we have our test scores again. Using this data, create a histogram. I'm going to use the same kind of bins to place them in the frequency distribution table. So I have scores from 70 to 79. I have 80 to 89. I have 90 to 99. And I have 100 to 109. And so we want to just mark down how many times that happens. So 90, 85, 88, 95, 100, 77, 85, 100, 80, 77, and 90. And you should notice that we have the same number. We had 2 in the 70s, 4 in the 80s, 3 in the 90s, and 2 in the 100s. That's the same thing that happened here. So 2, 4, 3, and 2. I'm going to do what's called a break in the graph because I don't want to have to do the 0 to 10 or 0 to 9, 10 to 19, 20 to 29, and so on. So I'm just going to start at 70 here, and then 80 would go here, 90 would go here, and 100 would go here. So then from 70 to 79, I would be at a height of 2. From 80 to 89, I would be at a height of 4. From 90 to 99, I'm at a height of 3. And from 100 to 109, I'm at a height of 2. So there's my histogram based on my frequency distribution table. Okay, box and whisker plot. So this uses a 5-number summary. The minimum, the lower quartile, the median, the upper quartile, and the max. And the lower quartile and the upper quartile we can abbreviate as Q1 and Q3. So again, we're using these test scores. And I'm going to put these in order. Let's see if I can slide this down a little bit. I'm going to put these in order right there so that I can find that minimum point that I need. So we said there's 77s. And then it was 80, 85, 85, and 88. 90, 90, 95, and 100, and 100. Okay, so then to find the values that we need, the median we know is just our middle number. So we're going to take off the ends until we get there. So I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I should have one middle number. Looks like 88 is my middle number. So that's my median. I know that my minimum is right here at 77. My maximum is right here at 100. Now, your Q1 and your Q3 come from the median of half of the values. When your median is one single middle number, you don't include that median. When your median is two different numbers and you have to average, you include the two numbers from your original data. So since we have this single number here for 88, I'm not going to include that. So I'm going to find the median of this first half of the data. And so the median here is 80. That's my Q1. The median of the second half of the data is 95. That's my Q3. So just the middle number of the remaining data. So then I know that I'm going basically from 70 to 100. So if we need to write it out, minimum would be 77, Q1 would be 80, median would be 88, Q3 would be 95, and maximum would be 100. Okay, so I'm going to put a dot at 77. I'm going to put a dot at 100. I'm going to put lines, vertical lines at Q1, 80, median, 88, and Q3, 95. Those lines form the box part of the box and whisker. And then those out to those dots are the whisker part. That's what a box and whisker looks like. So this is your minimum, this is Q1, this is your median, this is Q3, and this is your max. Hopefully that's coming back to you from a previous math class. Alright, rather than do that by hand, you can calculate one variable statistics in your graphing calculator. So you enter all of the data in L1. So go into Stat, Edit, in L1, make sure there's nothing in L2, L3, and so on. Type in all of these numbers. And you may want to pause your video so that you have time to do this. Then you're going to go to Stat, go over to Calc, and just hit one variable statistics. It will give you all of this data. So if you haven't paused the video, go ahead and take a minute now to go and put all of that in and try to follow these steps. So then when you have done that, you should get X bar, or your mean, to be 48.78. You should get your range to be 18. If that's not directly given to you, you can find your max and your min. Those should be listed out, and you would subtract them. Sigma, standard deviation, is 5.27. Q1, your median, and Q3. So median I get is 48, Q1 I get is 44.5, and Q3 I get is 53. Alright guys, that's all I have on this. So if you have any questions, feel free to come in and see me. Otherwise, I will see you in class.